Yeah, good morning and good evening, everyone. Yesterday, we started discussing about the few other AWS services. Those are very important as part of the computing purpose. Okay, so those are like, first, let me create the VPC. I'm creating VPC and then firewalls. Okay, so yesterday we started discussing launch template, and then before that, target group. So what is target group is nothing but you can compare this with our team, for example, DB team or development team, something like that, some team. If you see this diagram, okay, so remember 2 points. Every component should have its own security group. Okay, at least in production, every component should have its own security group. And our cart component will call catalog component. So in the auto scaling world, like for example, if the traffic is very high, catalog instances will be more. Instances will increase themselves automatically based on the CPU utilization or any metric you take. Okay. So every component should have security group. These 2 points, remember this. Every component should have its own security group. Okay. And in the web tier and app tier, calling from one component to another component, the traffic must go through the load balancer. Okay. If you have only one instance, if that instance is fixed, you can directly call from cart to catalog. If there are multiple instances like catalog 3-4 instances, user 3-4 instances, web 3-4 instances, then calling to the other component must go through the load balancer, because uh, the load has to be managed, and the load has to be diverted based on the number of instances. Okay, and this is also a very simple point. Every component should call other components through load balancer. Okay, so that is the purpose of load balancer, right? If you have multiple instances of catalog, okay, you should have load balancer, and this cart should call the catalog through the load balancer. So that's the way applications will work. Okay. Database is the different story. That is a clustering purpose. The database is a clustering concept that we will discuss later. First, let us concentrate on web and then app part, and load balancers, auto scaling purpose, because these are very important in our daily life. Okay. So target group, this is just like at some team. All instances are under one target group for a component. Okay. For example, catalog target group, user target group, etc. Okay, so this is this, and then launch template. Auto scaling will use this to increase the number of instances based on auto scaling policy. The policy is like, it will be continuously measuring the CPU utilization, average CPU utilization. If the CPU utilization is more than 60% or 70%, then auto scaling will automatically increase another instance, and it will take the input from launch template. Okay. And auto scaling, we know this already. Okay. Based on auto scaling policy, instances will be increased or decreased. Okay. that is auto scaling. And then what else? Listeners. Okay, load balancer, especially application load balancer. Balance the load between instances. Okay, it is intelligent. We will see that now, why it is intelligent. Okay, and then listener. ALB should listen usually on particular port. Okay, so we know that, right? Whenever we install Nginx, that is generally listened on port number 80. If it is HTTPS, then it will listen on port number 443. Okay, so you have to provision the load balancer and you have to select the listener, and then rules. Okay, so ALB will validate the rules and forward the request. So this is not new actually. So this is ALB is using Nginx in the background. AWS is using Nginx. If you see the Nginx documentation here, like this documentation. So this is Nginx is the load balancer generally. It is listening on port number 80, and you can see how intelligently it is routing the request between the components. If the request comes through like this API catalog, then it is sending to the local host on port number, I mean, generally like catalog component. And then if it is user, it is sending to the user component. So the similar way here also, we will implement the rules. Okay, if the request is something like /API/catalog, then go to the catalog component. And if the request is something like API/user, then go to the user component. So that is the rules here. Okay, how we implemented that. So that we already know that, right? One second, where is this? Yes. Okay, so here we know already PowerShell shell, and here there is PowerShell configuration. Okay, so this is the routing. These are the rules. The same way we have rules in our ALB also. So ALB is implemented using Nginx in the background. AWS implemented ALB using Nginx only. So nothing different, the same concept. Okay, so now, yeah, so we got all the VPC, and then security groups are created. So at any point of time, visualize this diagram and then understand MongoDB is called by the catalog and some other component. Just understand that. Okay, what is the, who is the destination, who is the source? Okay, here MongoDB is the destination, catalog is the source. It's just like that, you have to visualize the security groups and then give the rules here. Okay, so we created firewalls, and let us see our VPN. Okay, removing this. A VPN security group is already created, and you need to export that also. VPN security group is already exported, VPN security group ID. And now here, while creating the VPN instance, source AMI data is good, and then instance type t2.micro VPN security group ID. Now it's not this one. You need to get the data source. Okay, like this. You need to get it from the parameter store. VPN security group ID. That's it. Okay, now change it to data dot AWS SSM parameter dot VPN SGID dot value. Okay. Yeah, and then subnet ID you no need to give, it will automatically take the default VPC. Okay, so that's it, the VPN. Now let us create VPN. So after a few days, generally we will install VPN software itself, just like our Cisco VPN or something else. Yeah, VPN instance will be created. Is this parameters.tf line number 4? What is the error? Because I'm not creating VPN ID here, so I no need to export. Changed. So this is the one. This is nothing here. Okay. So that is VPN. Now MongoDB. Then security groups are all created, so we can remove these things. The MongoDB instance, make sure the data is MID is there, instance type, and then this one, it is not like that in our data. We need to get MongoDB SGID. Okay. MongoDB SGID. Okay, and yeah, refer now this one from data source. Data dot this one. MongoDB SGID dot value and subnet ID. We are storing it in database subnet, and then MongoDB.sh. We are installing MongoDB, and yeah, that's all. So this MongoDB will be created. Okay, so now we need to create catalog. So catalog component is not like the database components. Okay, these are the ones handling the load. It should be under load balancers and auto scaling. Okay, so database story is different. Database we have to handle through the database clustering. Okay, we will discuss that later. If we discuss everything at a time, you will confuse a lot. Okay, so for this iteration, the concentration is on load balancers and then launch templates, auto scaling, target groups, and rules and listeners, and HTTPS as well. Okay, so now we are going to create. First, actually, this catalog should be attached to the load balancer. So before provisioning these instances, we should have the load balancer exist. Okay, so generally create load balancer and then create listener. Okay, one listener is very important, you know that, right? So whenever I'm installing Nginx, automatically it will start port number 80, but here you need to give the listener manually. So we can use the modules Terraform, AWS, ALB. We can use this module. Okay, but these guys are making it more complicated through a lot of options. Okay, so what we can do is first we learn manually how the application load balancer, listeners, rules, everything is working, and later you can use the modules. Okay, if you do it everything by your hands, like creating the resources with your own, creating the resources on our own, then using the module doesn't matter. Okay, or you can create your own module also. Since it has a lot of components involved, let us understand to the low level how this everything is working on. Okay, so first create load balancer. I'm directly creating through the resources. Sometimes using the modules from the internet will make our work more complicated. Okay, so that is why sometimes we need to use our resources also. So AWS ALB Terraform. You can use this now. No, not this module resource. Okay, first I need to create ALB and listener. Later, I will attach all these components one by one to it. Okay, that is the thing you need to we need to do right now. You can see right side, we will have the resources, AWS ALB, AWS listener, and AWS listener rule, target group. We have everything. So no worries. So let me copy this listener. Okay, I'll create 04 app ALB. Okay, main.tf as usual, provider.tf, variables.tf, and then data.tf. Obviously, we need to export few parameters so that other components will use them. Parameters.tf. Okay, first let me copy the provider. Provider, I will use it as app ALB. Okay, and then this is our main. Oh, sorry. This is the one. Okay, I'm calling this as app underscore ALB, and name can just give. Let us try to keep the variables. Okay, so that maybe we can see var dot project name. Okay, hyphen ALB, for example. Okay, let me copy few variables also. Project name, environment, and this component is app ALB. Var dot common tags dot component also I can var dot common tags dot component. Okay, so now it will come as RoboShop app ALB. Internal true. Okay, so you know this is going to be the private load balancer. The internal should be true. Private is nothing but internal, and load balancer type is application load balancer. We have other load balancer like network load balancer. We will discuss that later. And then security group. So I need to have app ALB security group. App ALB security group we already created here. Let me get it. Okay, VPC ID and then app ALB security group ID and app ALB security group ID. Okay, just think while I'm writing and correct me if I'm doing some mistake. Data dot value. Okay, attach the security group and subnets. So obviously I need to provision this in private subnets. Okay, so private subnet IDs. Okay, so here we need to just use split based on comma and then data dot this one. Okay, so this will give us a list of private subnet IDs. So at least creating using two subnets is mandatory for high availability purpose. That's a condition from ALB. Okay, you need to have it. You need to give at least two subnets. Okay, you can enable this generally. Actually, what this will do is accidental deletion. For now, no need. If you enable this, you cannot delete it accidentally. Okay, logs not now. Tags, we can just have var dot common tags. Okay, so that's all, very simple. ALB, what is the name of the ALB? What type of the ALB? What is the security group where you want to provision? So this is very simple. Okay, so now let me do Terraform init. Terraform apply auto approve. Okay, so this will provision the ALB, but listeners we haven't created. ALB is provision, but we haven't selected the listener. We will select that now. Listener. Okay, let's wait for it. RoboShop app ALB. Better I keep it. So this will take usually 2 minutes time. Okay, so this will be created. We need to add the listener. Okay, listener, just let me take the syntax. So 443 is not required because it is internal. We can go for port number 80. Okay, this one. Let us take this one. So for a private or internal load balancers, you no need to have port number 443 enabled because the complete traffic is within our network. Okay, HTTP listener, and then load balancer you need to give. Obviously, this should go and attach to the load balancer. AWS ALB.app.ALB.ARN. Okay, port number 80 HTTP. This is fine, and let me give it as fixed response so that it is good for testing purpose. Okay, fixed response. Okay, so you can say, so this is the fixed response from app ALB. Okay, so this is the default action. This is nothing but default rule. So this will add, so this will add one listener on port number 80 and one default rule. Okay, so if someone hits on port number 80, the default rule is this one. Just like, you know, when we hit Nginx, we will get some default index.html, right? The same way here it is. Okay, so this is done. You can go and check here. This is active. Okay, but listeners and rules are not configured. And you can check the security group also. Security group is there. And this security group is allowing traffic from only VPN and what else? Web application load balancer. Okay, so only VPN because it is private. Now let me run this Terraform apply auto approve. So let me connect to VPN. And this is done. Okay, HTTP 80 is added, and in that we can see one rule. Okay, the rule is default, and you can check fixed response you will get. Okay, how can you check this? Let us hit this DNS name from VPN. So this is the fixed response from app ALB. So our ALB is working. And now what we have to do is we need to create a record also. Create Route 53 record. So why I'm creating Route 53 record? Because whenever you are creating and then removing the resources like ALB, each time the DNS name will be different. Okay, you can see this. So this is something random ID. Okay, this is some random ID. So once you delete and then create again, this one will be changed. So instead of that, I will create a Route 53 record for this so that I will call on the DNS, not on the. So these are all ephemeral. Okay, these are all ephemeral. It means temporary. All these DNS names, IP addresses, these are all temporary things. So you should always have some DNS to map them so that users will not be affected. Okay, now create record. Okay, so now for this entire, I'm using single load balancer for all the components. If it is a really big project like Amazon, okay, you will have separate load balancer for catalog, separate load balancer for user, separate load balancer for cart, separate load balancer for shipping. Every component will have its own load balancer. Okay, that is anybody, we can do that, no problem. But that will give us a lot of cost. Okay, so as of now, for our traffic, it is not required. And the real advantage of ALB can handle millions of requests actually. It can handle millions of requests, a single ALB with the rules configured properly. That is the actual advantage that we are going to learn actually. So now what I'm going to do is star.app. Okay, I'm giving some generic catalog.app. Something like that generally. Okay, if you select alias here, it will ask us to select load balancer in which particular region, like US East one, and you can select this and create record. Okay. So now anything, any star that catalog.app.join.devops.online, it will work. Now you can just search the, hit this CURL catalog.app.joindevops.online. Okay, can use anything. So it means the traffic is going through the load balancer. Something dot app. Okay, so the traffic is going through the load balancer. Now I need to delete this record and create through the Terraform. Okay, AWS Route 53 record Terraform. Okay, let me check this. Now we are using the module. So this is a little different. You need to select alias. Okay, like this. For that purpose, you need to give some zone ID. So in UI, you are selecting as you wish, like which region, okay, which load balancer, everything you are checking. But here, instead of selecting that names, everything, there is something called zone ID. Whenever you create load balancer, so there will be something called zone ID somewhere. This one, you can see this one, hosted zone. Okay, you need to give this ID to create the record. So for that, that is our AL. this one. Here you have that output actually. You can see zone ID. So you need to export this. Why I need to export? I'm creating the record directly here, right? So no need to export. I'm copying this and then zone name, you know that. Join DevOps.online. And I need only one record. No need of depends on. This is star.app. Okay, and here the name is AWS LB dot app underscore ALB dot DNS name. Okay, so this is the one exporting it, right? You can see DNS name is exported. Okay, AWS LB dot app ALB and then DNS name. I'm giving this value and the zone is AWS underscore LB dot app underscore ALB dot zone ID. Okay, that's it. Nothing much. So this will create the record. So I created a load balancer. I added the listener, some default rule, and I just created the DNS record. So because the ALB DNS name is not permanent, whenever you destroy and apply again, so the DNS name will be continuously changing. So it is good all the time you have some top 53 records so that your application will not be affected. So this is one-time job for all the components, right? So like application load balancer creation. So, and these components will go and individually add them as the rules. We will see that now. Okay, now you can see the records here. Okay, you can see the record. This is added property. Fine. So now it is our catalog component. We are going to configure 05 catalog. Okay. So in this catalog, again main.tf and then variables.tf and data.tf and provider.tf. Okay. So let me copy this provider. I'm making it as catalog. Okay. And let me init this and do our job. Okay, now focus on this now. I need to create target group. Okay, I need to create launch template. I need to create auto scaling. I need to create auto scaling policy. So the same kind of work for all the components. So focus on this right now. Target group, launch template, auto scaling policy, and I need to add rule to the ALP listener. So these are the 5 tasks we have to do. Okay, so we will write. Generally, whenever you are doing also, you will write and then do it so that it will be good for you. Okay, so target group. Here you can find this target. You can see target group. I'm just giving it as catalog target group. Okay. You can just give variables. Component is catalog. Okay. And just call this as var.project name hyphen var dot common tags dot component. Okay, and this one, our components are all running on 8080 and HTTP protocol. VPC ID, you need to get the data source. Okay, and VPC ID you can just give data dot VPC ID dot value. Okay, so that's it. And you should have some health check. Okay, here there is no example, but we can see. So there is a health check option, and yeah, we will enable this health check. Yeah, the syntax will be highlighted automatically. Enabled is true, and healthy threshold. Yesterday we have seen this. If continuously 2 health checks are success, you can consider as healthy. If 2 health checks are success. Health checks is nothing. Generally, you will call multiple times the URL. Okay, if it is success for 2 times continuously, you can consider it as healthy. You call the URL like 4 or 5 times. Generally, if still you are not responding, you will consider it as thank you. This is variables. Okay, thank you. So naming the files doesn't matter generally in Terraform. Okay, you should just have .tf extension just for the, and it's good. You should have the proper name to consider as healthy if 2 health checks are success. Okay, and then interval. Let us make it as 15 seconds. Every 15 seconds, we will check the health of the component, and then matcher. So matcher is 200 to 299. Any response code within this range is considered as success. Okay. And path, all our components, our developers enabled a path like health. Okay, you will get the response if the component is healthy. Okay, who will give this? Our developer will give us, so don't worry. And then port number, which port number? Obviously on port number 8080. Okay, and protocol is HTTP. And then timeout. Timeout is 5 seconds. If you don't get response within 5 seconds, you can consider it as failure. Unhealthy threshold. If at least three consecutive requests are failed, then you can consider it as failure. I mean, the component is not healthy. Okay, so this is the target group generally. Okay, let us create this. Terraform apply auto approve. Target group is nothing but I'm creating a team. And health check is nothing but I'm defining some standards. If a team member is working, I mean, he has the specific skills or not. You take 10 persons, how can you validate they are eligible to within your team? Because you need to define few parameters and then test the team members whether they are eligible for the team or not. So that's what I'm saying. I'm naming a team and then I'm checking continuously their performance. Where is your target group? Okay, so this is created. Health check will be done by generally load balancer when we implement that. Okay, not right now. We just create a target group. That's it. Okay. And after that, let us create the launch template. So launch template we have here. Launch template. Okay, AWS launch template. There seems a lot of options, but no worries, we don't require those options. So this is catalog launch template. Naming it as this one. And this is, we don't require extra. Our AMI has some default volume that is enough. So this is not required. This is not required. This is not required. These are all options are not required. Okay, image is required. Let us get the data parameter. Okay, so I am selecting data dot value. Okay, instance shutdown terminate. Don't require this one. T2.micro kernel ID is not required. We are not using keys and no need license. It's open source image. Need this. Monitoring is not required because they will charge again. Placement, we will be selecting this through the auto scaling. This is not required. And security group IDs. We have the security group ID created for catalog. Catalog SGID. Catalog SGID. Data dot catalog SGID dot value. Okay, user tag specifications. This is instance. I want the instances should be named as catalog. Okay. And then user data in launch template, they say base 64 is must. Okay. So user data base 64 encoded. So that is why I'm just using this function file base 64. It will convert the text into base 64. You can just say catalog dot sh. Okay, let me get this catalog dot sh. I will see what is there. But generally, do you think we will use this user data whenever we are going for deployment? Please answer in the chat. So is this the right way to have user data for deployment? Yeah, it's not the right way. Just for the sake of right now, our concentration is on Terraform and AWS resources. For the sake of application completion, I'm using this. Okay. But in real time, we will go for Ansible for the deployment and configuration. Okay. We will do that in next iteration. So catalog.sh. So this is our catalog.sh. Catalog.service. Actually, I need few changes because we are doing the, for example, if you take code.service, we are not using this domain actually. We are using catalog.app.join-devops.online, right? So instead of disturbing this, I'm just creating another one. Okay, that is RoboShop shell. I can say TF. Okay. Here I will do some changes. Rename this. Second, let me open it again. Okay, this is 7. So here I'll do some changes. Just I don't want to disturb this because a lot of you guys are practicing again. So that is fine. Catalog.sh, catalog.service. This is there. This is not a problem. And yeah. So did I forget to create the record for MongoDB? That is our MongoDB. Yeah, I need to create the record also, right? So just copying this. Need to create the record. This right now hard coding, or you can have it in variable zone name default equal to join DevOps dot online. Not looping. So this is MongoDB dot join DevOps dot online a record, and then the IP address is going to be module dot MongoDB instance dot private IP. Okay, so I created the Route 53 record. Just I want to apply this. Okay, so record will be created. Load balancer is ready. Now catalog. So this one, let me take to MongoDB.sh. Similarly, I will use catalog.sh. Okay, we are going to hand over this to the Ansible, but later. Okay, but I need to push cd/c /DevOps AWS repos Photoshop shell tf git init git remote add origin. Okay, I'm going to create one repo. Git remote add origin. Oh, I just copied it, right? So I need to remove this dot git init git remote add origin git add user data. Okay. I can copy this. So this will be cloned and catalog.sh will run. Okay, but here it should be, you can just see this RoboShop shell. User add and there's something to copy. The path is correct. This is fine. And so it is downloading to the temp directory and unzipping it. Oh, you can see this. So this is actually /home/CentOS. So I need to change the path here to /home/CentOS. Okay, that's it. Now let us go to catalog and then Terraform apply auto approve. So this will create target group and launch template. So and now we need to create the auto scaling. So some error. This object has no argument. Okay, this is not value. This is not SSM parameter. Okay, this is from data source. Once template is getting created, you can just see this launch template. Okay, RoboShop catalog is created and yeah, everything is done. Okay, now we need to create auto scaling. That is the third step, an auto scaling policy. And then finally, you need to add the rule to the listener. Okay, let's have 4 minutes break. We can start at 8:04. Yeah, these two are done. Create a target group and launch template. Now let us create auto scaling. Just search auto scaling. Okay, you can see AWS auto scaling group here. Taking this. So this is catalog auto scaling. And name I'm giving like this. Okay, maximum size fine. 5 can keep it. Minimum size 2 and desired capacity is 2. Okay, health check grace period. Yeah, first our instance need to take some time, right, to install, to run the bootstrap script, like user data script. It will take some time. So I'm giving as 300 seconds. It means 5 minutes. Okay, within that 5 minutes, it can complete that installation. Okay, health check type, you can keep it ELB because the health check is from the load balancer. So if who is sending traffic to the catalog component generally? Please answer in the chat. So what is the middleman here to route the traffic? So obviously load balancer is routing the traffic. So it is load balancer responsibility to check the health of the instances. So load balancer is continuously checking the health of the instances. Okay, if it is healthy, then only it will pass the traffic. Otherwise, it will not. Okay. So yeah, and this one placement group is not required. Force delete is not required. Launch configuration. No, it's not launch configuration. It should be launch template. Launch configuration is old way. Okay. So you must specify launch configuration, launch template, or mixed instance policy, either of this. So as I'm choosing launch template. Okay. I'm choosing launch template. AWS launch template dot catalog dot name. Okay. And VPC zone identifier is nothing but our subnet IDs. So now for a high availability purpose, what I'm doing here is I will launch the instances in multiple availability zones. For example, AZ 1A is down, still we have the instances in AZ 1B. Okay. So we need to have private subnet IDs. Private subnet IDs. Okay. Data dot private subnet IDs dot value. Okay, I'm choosing in 2 availability zones. This is not required. Okay, tags is name as catalog. Okay, that's it. AWS launch template. It should be like this. You need to mention the version also, not like this. I'm to mention the version AWS launch template dot catalog dot ID and latest. So every time I will take the latest launch template version. Not dot ID. Yeah. Okay, this tag is not required. So this is the auto scaling. Terraform apply auto approve. So the same process we are going to implement for all the components in web and app. Okay. So it is created and it is updating the capacity. Okay, 2 instances are created. Yeah. So catalog instances are created. It will take maximum 5 minutes to bootstrap themselves. Okay, so that is auto scaling. And you should have some policy here. You can just see here in the automatic scaling. So you need to tell them based on what policy you need to increase the instances. Like in our daily companies. So if a team like 5 members, they are continuously getting 8 hours work daily. So it is always good to have some extra resource so that they can share the workloads. They can another person can support, right? So that same concept here. So based on the CPU utilization, you can always create some policy. If all the instances are getting at least 70% of the load, then you can increase for the safety, you can increase another instance. Okay, error in catalog user data. What is it? Catalog.sh. Okay, let us check this anyhow. The instances. The such CentOS. Okay. tail-f var log cloud init output.log. Catalog.sh. What is the error? This error here. Line 4 change directory. Oh yeah. Thank you so much, Abhishek. So now no option. I need to destroy or form apply. You can create another version, but for the simplicity, right now I'm destroying and then creating again. Okay, so we are discussing on this one, right? Okay, I saved it. Yeah. This one auto scaling. So you need to give some policy. That policy is, you can see this target tracking scaling and then average CPU utilization. That is it's your wish, like 50 or 70 or 80. So definitely it should not be more than 80. If an instance is used 80% of its capacity, then it is always safe to have another instance. Okay, so for that purpose, I'm going to have auto scaling policy here. So this auto scaling policy, we have many policies, okay, but we are going to select target tracking scaling. Okay, target tracking scaling. Target tracking scaling. This one. Target tracking scaling. Catalog, just naming it as catalog. Average utilization. Let me keep it as 50%. And other configuration is nothing but this one, which auto scaling we need to give that, right? Auto scaling group name and policy type. Okay. What is auto scaling group name? AWS auto scaling group dot name. Okay, so this policy is going to attach to this catalog auto scaling, and you can just give it as CPU, and policy type is target tracking scaling. Okay, this is the one we use generally in our companies also. Okay, yeah, we are in progress, right? Now I'm applying. Okay, then target group, launch template, and then auto scaling group, auto scaling policy, and then finally listener rule. So this should go and attach to the load balancer. So that is listener rule. Go to elastic load balancing listener rule. Yes, so now we have to attach these instances to our auto scaling group. Catalog, and then listener ARN. So what is the listener ARN? So we have it here in the, let us check whether it is created or not. It's getting created. So listener rule, where is our load balancer? This is our load balancer, and here, so there is our listener. Okay, so it should come and attach to this listener. So obviously you need to give listener ARN. So I need to export that first. How can I export? We get some syntax. Listener ARN. App ALB listener ARN. Okay. And then this is AWS listener.http.ARN. Okay. Now I run this 04 Terraform apply. So this is exported. Same time I need to get it. Copying the syntax, and then inside data, I'm keeping it app ALB listener ARN. So go and attach to the application load balancer, listener ARM. Okay, priority, I'm making it as 10. Okay, let's have 10, 20, 30 like that. And then action type forward and target group. So we know our target group, catalog.arm. And on what condition? Okay, it's not path, it's on something like this. Catalog dot app dot join DevOps dot online. Okay, so if you get the request on this host header, then forward the request to the catalog group. So that's what it says. Now, when I run this, you will get more clarity. 0.5 Terraform apply. Let us see this auto scaling got it or not. Okay, you can see the policy is added, and let us see the instances are successfully configured or not. Tail -f var log it output. So it's going on, not a problem. Let it. Now let's go and check this load balancer. Regional rules. We have one rule. Okay, you can see one rule based on priority 10. So we have a rule. Let us go here and then just edit rule. So if the host header is something like this, if someone calls catalog.app.joindevops.online, so then send it to the RoboShop catalog target group. Now just visualize this. If cart wants to call catalog, how will it call? It will call catalog.app.joindevops.online. So that request will go to the load balancer, and then load balancer have this entry of rule. Then it will send it to the catalog target group. Okay, that's it. Now I can see that anyhow. Copying catalog.service failed. Why is it failed? I just go and then check here. Catalog.sh. ls-l. Okay, so inside the script I have given as RoboShop shell, hard coded. Okay, so I need to change it. Catalog.sh. This RoboShop shell, I need to change it to the RoboShop shell -pf. Okay. So it is fine. Now let me destroy and approve. But usually you can create another template version. Okay. So that one, how to create AWS launch template, another version to Terraform. So these guys are saying from UI, but it is okay. That is least priority for us. Can do it later. Yeah, so this is how you add the rules and let it come up, and then we can hit that so that we will get the response. Okay, but you need to understand one thing here. So what is that? Okay, so you know from the front end last time when you configure it through the shell script or Ansible, whatever. Okay, so the request is like, for example, 42.45 dot something like 23.12. Okay, so this is the request. How the catalog component is called? /API/catalog/categories. Okay, so this is the URL it is called, and you can see the here. So if you get any request based on this, what is this Nginx is doing is it will remove this path. Okay, it will remove this path from the request, and it will send the request as like this. Categories. Okay, so this will be suppressed. That's what here we have. Okay, so this will be suppressed, and whatever the pending after this one, so that will be added to this one. And one more thing here. Yes. Okay, so that is the concept actually. Now we are going to check that. It is adding. Scaling is created, so it will take the instances some time. Okay, let it run. So now what can we do here is, now you need to create this public load balancer. Okay, because web has to go and attach itself to the public load balancer. So now I need to create this public load balancer, and then we can attach this one. Okay. Now what I do here, /06 web ALB main.tf variables.tf and then data.tf parameters.tf parameters.tf, and then what else? It is provider.tf. Okay, so here the provider, copying it, web ALB. Okay, so this is done. 06 web ALB, initializing this. So now you know creating ALB, that is, we know that very well. So we just now created. Let me copy that. But is this internal? Can someone answer through the chat? So I'll be asking a lot of questions now. You can just reply that in the chat. This is not at all internal. So this is, we are going to give it for the public. So internal is false. Okay. And load balancer type application is fine. And then here I'm going to create web ALB SGID. Now which subnet I have to give this, public or private? So it should be public. Okay. So let me copy the tags for variables. And this is web. I keep it small. Web ALB. And then the data, required data. PC. This is going to be web. And this is going to be public. Okay, fine. Web ALB, public subnets. This is good. That's it. Now Terraform apply auto. So again, it will take 2 minutes time. Okay, it's fine. And just let me check this. Our EC2 instances are going fine or not. After such CentOS DevOps 321 tail -f var log cloud init output. Oh, yeah. What is the problem? Yes, changes not pushed to the GitHub. Okay, so anyhow, let me push again. Terraform. So actually, this is not the way. Actually, you should release another launch template version, and then you have to update auto scaling. Okay. So we are getting our web ALB. This is at least let us wait for that success. So web ALB is getting created. Now I need to configure the listener. So should I do it on port number 80 or port number 443? HTTP or HTTPS? So this is exposed to the public. If I give it HTTP 80, then obviously your URL is not secure. So it will not come like this. Okay. Because it is public, whenever something is public, you have to always encrypt like HTTPS. Okay, so here now the listener is going to be let me copy that listener syntax. So this listener is going to be HTTPS and obviously it is 443. Okay, load balancer ARN web. Oh, I used again app ALP. So name should not be like that. So no other option. Destroy and apply. Because if this name you have to change, definitely you have to remove the resource and create again, or else you need to edit the state file. Okay, editing state file anyhow, don't want it right now. So it should be at least now web ALB. Okay, web ALB dot, this is HTTPS listener and ARN. Okay, 443. And if you have given 443 as listener, then you need to select the certificate. Okay, so what is the certificate here? You can see this is the HTTP. So you can see that certificate information here. Okay, so this is the certificate. So this certificate will be issued by generally some third-party providers. Okay, but here in AWS we have a certificate provider. So that is ACM, Amazon Certificate Manager. If you go here, Certificate Manager, ACM. So here you can request for certificate, request public certificate, next, and then you have to provide your domain name. Otherwise, it cannot issue the certificate. My domain name is joindevops.online. This is my domain name. And you can add multiple domains like star.joindevops.online, whatever. Okay. DNS validation, because our Route 53 is here. This is the reason I created Route 53 hosted zone in AWS. Okay, because your hosted zone is here and then your ACM is here, we can do the immediate validation. And then request. That's it. Just you need to give your domain name. If you open this validation, you can see you have to create these records in Route 53 so that AWS can verify your authority on this domain. For example, if I give something else like facebook.com, it will create the certificate, but obviously it has to validate. So it will automatically create the records if you have that domain. So if you have this domain available, it will automatically create the records. You can see this now. So that is how validation is done. Certificates. Join DevOps.online. I created, right? Why it's not shown here? Create records. Successfully created DNS records. Yeah. Now you can see this is the validation. This is DNS validation. So if AWS is able to create the record in this domain, then obviously it is verified. If you don't have this domain, obviously it cannot do the record creation. So now it can see, we'll wait for a few seconds and then it will be say is active. Maybe 1 or 2 minutes generally. Let us check catalog instances again. Such CentOS. tail-f backlog cloud init. Okay, so now it is success. Okay, so now coming out of it, now I'm in VPN server. Okay, now I'm calling cur catalog dot join DevOps dot online slash categories. or /health. Sorry, it is catalog.app. So maybe still it is not healthy here. Go to target groups, catalog target. The load balancer. So in this load balancer, rules, Photoshop catalog, and here instances are not registered. I did a mistake. Here instances are not registered because in auto scaling, so I need to inform auto scaling to register the instances into the particular target group. I forgot this. Now you can see AWS auto scaling group. You can see you need to provide the target group so that it go and register the instances into that particular target group. Okay, right now the instances are created. Instances are created, but those are not added to the target group. So obviously you will not get the response. So inside this target group ARNs, okay, you need to give the target group ARNs. You need to give our AWS target group. Where is this? AWS LB target group dot catalog dot ARN. So this is a list actually. Provide like this. Okay. So now AWS auto scaling will add the instances, just like HR. HR is taking employee to the company, but if they don't add it to the particular team, obviously it will not work. Okay, so the same, I forgot to mention this earlier. Okay. Now this will add the instances to the target group. Now let us refresh. Okay, now we got the instances and health check immediately started. Okay, so now all instances are healthy. So it means we'll get the success response. Now if I hit this, okay, you can see I'm getting app okay. What is the code? Now let us understand how the request is going. Okay, you need to answer with me. 200. So I'm hitting from VPN, right? So this is the VPN server. So from VPN, where is it going actually? I'm giving something like this, catalog.app.joindevops.online. Where is it going? So if you want to know where is it going, ns lookup. Okay, so what is the IP address of this? You know, star.app.joindevops.online. What is that? So this one, anything with star.app.joindevops.online, where is it going? It is going to the load balancer, right? So it is going to private load balancer. The request is coming here. Okay, and from here, so the rules will be validated. Now we will see what are the rules. What are the rules here? Where is this load balancer? So request came to this load balancer. Which port I hit that? So here port number. What is the port here? What is the port? What is this port? Port number 80. Sorry, this is catalog.app. So this is port number 80. So the listener, do we have listener on port number 80? Yes, we have. Now the first rule. What is the first rule? If you have something like catalog dot, if you have something like catalog.app.joindevops.online, I'm forwarding this request to the catalog target group. So that's what. So request went to the catalog target group and you got the response. Now, if I see categories, so I got this, right? This is the response, artificial intelligence and robot. Now I will change something from catalog to something else like user. So what happened? The first rule, port number 80, okay? Port number 80 listener, it went to the listener. And is this rule success? Is this rule success? No. So it is not success. Then it went to the second rule. Second rule is obviously this one. Okay. That's it. So this load balancer should allow the traffic from VPN on port number 80. Now you can see port number 80, it is accepting the traffic from VPN. So once again, I logged into the VPN server. I hit catalog.join app.joindevops.online. So that request is matching to the DNS of this one, private load balancer. And from here, I have a rule. If something, the host comes up with catalog.app.joindevops.online, send it to the catalog. Okay, and this catalog should accept the traffic from this catalog should accept the traffic from ALB. It is just like you are not hitting the catalog target group. You are hitting the you are hitting the catalog target group. You should get response. That's not like that. So that catalog should allow the traffic. Okay, let us take this. So this is the catalog. So this should allow the traffic. So this catalog should allow the traffic from application ALB. Right? If something goes wrong, I'm logging into the catalog server and then checking on port number 22. Right? This is the total flow. So now the same flow for all app components. Okay, but web component is little different anyhow. So this load balancer, web load balancer is success. Now I need to add the listener. Okay, so that listener, for now today I will add it through manually, and then on coming session we will do it from the Terraform. Okay, so we have the certificate, add listener HTTPS. Okay, port number 443. And for example, we don't have any instance, right? Right now, I'm returning the fixed response 200. Hi. So this is from web ALB HTTPS response. Okay, that's it. Add. So you need to select the certificate. I got the certificate anyhow, and add. That's it. And it is saying it is not reachable. Why is it not reachable? In the security group of web, I only allowed port number 80. If you remember, I only allowed port number 80. So I need to allow port number HTTPS 443 also from public. Okay, now you go and check it. Okay, so this may take some time. Now I hit join DevOps.online, but it should be HTTPS. Okay, you can see. Wow, this is something different. This happening here. Did I save it? Port number 443, and then one rule. That rule is fixed response actually. Hi, this is from this one. Join DevOps.online. What's wrong? Oh, I didn't give the Route 53, right? So obviously I have to give Route 53. Without Route 53, how will it work? Okay, don't give anything here. Alias, it should go to the load balancer and then US East one. And this should be our, not internal, this one. Okay, create records. Now you hit it. Now you can see this is secure. Okay. Hi, this is from web ALB HTTPS response. If you give HTTP only, it will not work. Okay. It will not work because I don't have any listener on port number 80. So that's the security I'm making it. So here I have load balancer. So this load balancer, inside that I have port number 443 only for listener. If you want HTTP 80, you have to give it another listener. Okay, this is the listener, and then right now I added the certificate, and this is the 200 response for now. So next session, what we do, we will attach the web instance to this, and from here everything will be called through the load balancer. Okay, HTTPS. Fine. So maybe while doing for the first time, we do a lot of mistakes in this, like as I did today. Okay, while giving user data and forgetting to add the instances to the auto scaling. But remember this concept of our general concept, like if the team is exhausted, HR need to take the extra resources, and it's their responsibility to send them into a proper team. Okay, and then each and every time you have to calculate their utilization. If they are utilized completely, it is obviously safe to have one more resource and then you need to add the rules also. Like you can say ALB is our team manager. If they get something related to the catalog work, they will send it to the catalog target group. So this is the story. Generally, it's a nice story. Now we can have few questions. Sorry, I took some extra time today because tomorrow no session. Any questions? Yes, Sheikh Ahmed.
Yeah, hi Shiva.
Yeah, hi.
Yeah, so mainly like here we are concentrating like to uh, like achieve the RoboShop configuration. So
Mm,
whatever the resources syntaxes we are copying from the site, like for
okay.
example regarding related to the listener,
Mm,
listener today we copied, like we have removed so many extra configuration syntaxes, right?
yes.
So like in real time, so do we need to make use of it, or like for example, we removed one license also today.
So that I cannot get the license. This is our
Yeah,
open source. So if you
understood,
have
understood.
license, like you can
So
get use
that's
red
what I
hat images. Yeah.
yes, yes, that's what I said. Like to achieve this RoboShop, so we are following all this. So exactly in real time, so do we need to keep all those
So
extra things and we
that
need to
is based on options. So obviously AWS will give you hundreds of options. So
Mhm,
no, just like it is giving the options, we no need to use everything. Okay. If we
mhm.
need, if I discuss about those options, that's it. Then this will go for a year, a year.
Yes, I understood. I understood. So
Okay.
that's what even we like as of like this is a complete new topic for us. So I'm just wanted to understood like what all and also regarding this some fast response we are giving, right?
Fast response. What is that?
Fixed response. Sorry.
Yeah, fixed response is
What,
just to
what,
test. So I created the load balancer. If
mm,
I don't have web instance to test right now. So this is
mm,
just for the testing purpose, whether
okay.
the load balancer is working properly or not. So I gave that fast response, something wrong. I am not getting response. Then I found, so if you're not getting response, join DevOps.online. So
Mm,
immediately you should think why I'm not getting response. So
okay.
first the request should reach to the load balancer. So how
Okay.
will it reach? If you have the record, it will reach. If you don't have record, it will not reach, obviously.
Yeah, so the mainly the actions are of three types.
What is it? Three types?
The fixed response. I saw the
Yeah.
three types of actions. Fixed response and some other.
Yes, we have actions. So just have some rule name, and then conditions. So you have a lot of conditions. You can have condition based on the path, based on the domain name, and based on the request method, and based on the IP address and queries. These are the things we have. Okay. And here, yeah,
Yeah.
forward, redirect, return fixed
Yes.
response.
These are the things. Okay. So yeah. So as of now, we have choose a fixed response.
Yes.
Yeah. The main concern of mine is the regarding that syntax selections only. So that's what I'm looking for. How it will be.
That's fine. So I just copied from the documentation. If
Mm.
you have some errors, manually, right? So yesterday we did manually. Now
Yes.
I'm doing through the syntax. Okay. So these are all the things for all our components, for all our web and app components. So if you guys are desperate, okay, you can create a module for these 5 components. Okay, so the module name can be like RoboShop app module. Okay, so this is our fully customized module. So what this module can do, readme dot what this module can do is this module will create following resources. What are those following resources for all the modules for all the components we are doing? First, what are we doing? Target group. And then next, what are we doing? You can type in the chat, guys. First target group I am doing. Next I am doing launch template. And next I am doing auto scaling. Next I am doing auto scaling policy. Next I am doing rule, add rule to load balancer. So this is common for all the components. Okay. So now I can create a module. Okay, but you have to give some what is this? You have to give the parameters through variables. Okay. So you have to parameterize this. What is the name? What is the port? You have to ask from the user. What is the protocol? What is the VPC ID? What is the health check? So these are all the things you have to get it from the user. Now today I created through the resources, and in the upcoming session, I'll make this module. Okay. I'll make this entire code as module, and simply I will call it for all the components. Okay. Any other questions from anyone? No questions. So the concept is very clear.
So just try to reduce the time of the video, sir. So
Yeah,
okay.
actually,
today
yeah.
it is okay. So
Yes.
it is crossing 140 minutes. 1 hour
No,
40 minutes.
I will
be
not
very
cross
difficult.
it 1 hour 30 minutes. Okay, because 10 minutes we are definitely taking for questions, and 5 minutes I'm taking for break. Okay, so maximum it will be 1 hour 30 to 1 hour 45 is rare cases. Today it is 1 hour 45. It's rare. Okay.
Yeah.
Because I don't have session tomorrow. Yeah, I respect your timings. You have offices, everything.
Thank you.
Yeah, thank you so much. If nothing else, yeah, so today you can practice well. But whenever you are doing, just remember this story. This will be good. Okay, this story is good. It's just common sense. Okay, but yeah, I understand like a lot of things to remember here. Whenever you are doing something, just understand why you are doing. Okay, this is the very important concept of any cloud auto scaling. Okay, yeah, so that's all.
Happy journey for your travel.
Yeah, thank you so much. Tomorrow we can have QA, and today also we can have QA. Bye. See you.